Hello guys, welcome to another video. In this video we'll learn about the mechanics of water erosion and the mechanics of wind erosion. First one is mechanics of water erosion. There are mainly 3 points of mechanics of water erosion. First one is detachment, transport and deposition. Detachment, transport and deposition. Detachment or loosening of soil particles caused by flowing water free and throwing of the topsoil and or the impact of falling raindrops. Here we can see the detachment. Raindrop comes into the soil and detachment occurs. Then number 2 is transportation of soil particles floating, rolling, dragging and splashing. That means after detachment, water transport in the lower soil, lower surface. Then third one is deposition. Deposition of transported particles at some places of lower elevation. That means in the lower elevation the particles are deposited. Deposition occurs here in the lower surface. Here in the picture we can see. So these are the main mechanics of water erosion. Then mechanics of wind erosion. Here is main 3 steps of mechanics of wind erosion. First one is initiation of movement, second one is transportation, and third one is deposition. And then first one is initiation of movement. The initiation of movement of soil particles is caused by several factors acting separately in combination. In the course of collision, grains rolling and bumping on the surface of some particles may bounded up. It occurs when the wind force or the impact of moving particles is strong enough to dislodge stationary of soil particles. Then number 2 is transportation. The transportation of the particles once they are dislodged takes place in 3 ways. First one is saltation, second one is soil creep, and third one is suspension. In saltation, soil particles of medium size 0.10 to 0.15 millimeter in diameter are carried by wind in series of short bounces. These bounces are caused by the direct pressure of the wind on soil particles. Then number 2 is soil creep. Saltation also encourages soil creep, rolling or sliding. That means soil creep means rolling or sliding along the surface of the particles, and the bouncing particles carried by saltation strike the large aggregates and speed up their movement along the surface. Then number 3 is suspension. When the particles of soil are very small, less than 0.1 millimeter, they are carried over long distance. Finer suspended particles are moved parallel to the ground surface and upward. Here is the picture we can see. First saltation occurs by the force of wind, saltation, and moving and rolling occur. That means creep, soil creep. First one is saltation, then second one is soil creep, and third one is suspension. Suspension, that means upward movement or surface, ground surface movement, parallel ground surface movement or upward movement. Here you can see in the picture. Then last one is deposition. Deposition of the particles occurs when the gravitational force is greater than the forces holding the particles in air. Deposition could occur when the wind velocity is decreased due to surface obstructions or natural causes. That means when the wind velocity is decreased and the suspends are deposited in the lower surface. So this is the process of wind erosion. First on movement by the force of wind, then soil creep, that means rolling, soil rolling, then suspension. Suspensions can be parallel to the soil surface or maybe upward movement. Then when the velocity decreases, the soil particles are deposited in the lower surface. Then solutions for reducing soil erosion. Actively participate in the soil conservation programs. Then number 2 is maintain a vegetation cover, especially in the vulnerable areas such as steep slopes or arid areas. Then third one is maintain livestock grazing rate to prevent overgrazing. And the last one is in cultivation areas, crop rotation should be used to prevent soil becoming exhausted. There are many solutions for reducing soils. These 4 are the main and common solution for reducing the soil erosion. So that's all for today. See you in the next video. Thanks for watching.